Okay, Scott back with you, and in our last video we talked about the basics of the electric circuit. That was our last crash course. The electric circuit, talked a little bit about parallel and series, and real briefly about how we take the measurements of volts, amps, resistance, power, how we get those calculations. How much calculations you're actually going to have to do varies. I haven't had to do that nearly so much. It's important that you understand, though, this parallel circuit, and that's what you're going to be working with the most. You're going to take amp meters on the in series, and typically your multimeter is going to have a clamp. You're going to clamp it around that wire while the system is running. You're going to take an amp reading. Amps are done while everything's working, while electrons are flowing. Voltage, you're going to measure voltage across the load or across an open switch. So it's going to be a measurement of the electrical pressure. Resistance is measured with the ohm setting on your multimeter, and your power has to be off or you're going to ruin your meter. So you take a measurement of the resistance across the load on both sides. Now I want to get into transformers, what a transformer does. This is a typical looking transformer. What transformer is doing, what it is doing is it's stepping down the power. And here's an example. You got 120 volts on one side. The wire is wrapped, or the winding is wrapped around this core. On the other side you have another wire wrapped. You'll notice on this one it's 1,000 turns, and on this side is 500 turns. And with that ratio, 2 to 1, you're going to be stepping down the voltage from 120 volts to 60 volts. Now a lot of step down transformers that we use for HVAC, they're 5 to 1. So you'll step down 120 volts down to 24. On a drawing, a transformer might look like this. And you've got 120 volts, 120 volts going in. Where's my little... No, that's not what I want. That's not a paintbrush. There we go. And do I have a color option? Yes, I do. Okay. So on my 120 volts here, I'm going to make that power black. That's going to be a black power line. And just pretend that this is wired up. This is wired up with a hot leg for 120 volts. This is my common or my neutral. So my black wire is going to hook up to one side of the transformer. And this wire is probably going to be white. That won't show up very well on here, so I'm going to make that just blue. So just remember this wire is actually white. Hook that up to there. So this is L1. This is my L1. And this is my L2. L1 and L2 high voltage hooked up to the high voltage side of the transformer. Let's take a look at that again. That is more than likely going to be on this side. There's 3 wires here because it's probably giving you the option of hooking up 120 or 240. It's giving you the option. And then on the other side it's going to come out lower voltage. So you're going to hook up your two lines, your common line, your 120 volts. It's going to come out here after it goes through the windings, and it's going to be stepped down to 24 volts. So my red is going to be my power again. And we're going to let that 24 volt power go into my thermostat on the red line. It's labeled red. That's my power going into the thermostat. the thermostat is a switch. And this is a little more complicated of a switch. Instead of this switch just being one way in and one way out, you've got 3 different possibilities for power to leave that switch. And with these colors, yellow is for cooling. This is yellow. White, which is actually blue here, just like my blue. White, well, maybe it's black. Anyways, white is for heat and green is for fan. So that power is going to go out. Let's go ahead and run this to the next thing, which is going to be a contactor. We're going to run this to the low voltage side of a contactor. So let me see. We're going to run that yellow 24 volts right there. Remember our circuit, it's L1 to switch, and this is the low voltage side of L1. L1 to switch, switch to load, and on the contactor there is a small coil, a 24 volt coil, and that coil is the load on the low voltage side of the system, and then that is going to come back to L2, and I'm going to let the blue wire, in this case it's actually blue, that's going to come back to L2. So now you've just hooked up a contactor through the thermostat. When you call for cooling, it's going to send a 24 volt to your contactor. It's going to engage that low voltage coil, and it's going to pull that contactor down. What does a contactor look like? Voila, there's a contactor. Here's the low voltage leads that are hooked up right there, the 24 volts. When they are energized, this pulls down, that pulls down, and it allows current to pass through. That's high voltage current. So there's the low voltage coil, which is your load. That's where the resistance is for the low voltage circuit. On the high voltage side, the contactor is a switch. So this device right here is both a load on the bottom and a switch for high voltage to pass through. You literally have 2 circuits being worked or run through this device. There's another pair of contactors, basically the same. You got your low voltage here, your high voltage passes through. Sometimes you'll see the low voltage on tabs on both sides. Sometimes you'll see the low voltage coming out on the bottom, like 2 tabs there. So yeah, every contactor is manufactured a little different. That is your contactor, and that is all I want you to learn right now. I want you to do a little search on your own on Google about transformers, some pictures of them. Thermostats are very, very similar. This is a basic thermostat. It's got your red, your yellow, your white, your green. And we'll get into wiring the rest of it later. But do a little side homework, maybe look at some YouTube videos that talk about thermostats, or some videos that talk about contactors or transformers. But the same basic concept that I talked about in the first lesson. L1 to switch, here's your switch, switch to load, load back to L2, and in this case it's a low voltage circuit, L1 and L2. This is L1 and L2 for your high voltage circuit. This is an example of a pictorial diagram. There's 4 types of diagrams. There's ladder diagrams, there's pictorial diagrams, there's functional diagrams, and there's schematic diagrams. Functional is more of those little boxes, and then schematics, usually what you see on the inside of a panel. When you take off a panel on an air conditioning unit, you're going to see the schematic. A lot of the symbols are going to be similar. So that is going to sum up that lesson, and we'll go to the next.